Hi class. So this is going to be your lesson for Unit 4, Lesson 3. We're going to learn how to come up with an equation for a polynomial graph, okay? And the graph of a polynomial generally looks like this. You would see a bunch of curves. You could see one curve or two curves or three, but it would go up and down like this. Okay, and what we're going to learn to do is how do we write the function for this? So basically, like whenever you're graphing something, you have a function. So you would have f of x equals, and then you would have your function here. And so that's what we're going to come up with looking at a graph. And also, one more note, we're going to write these functions in factored form. Okay. And so what we're going to do is the first thing is we're going to look at, well, the first thing I do is just look at to see if this is a positive function or a negative function. So it's a positive function if the end on the right side is going up, and it's a negative function towards infinity on the positive side is going down. So on the positive side, if it's going up, is a positive function, or if it's going down, then we call it a negative function. In this case, this is a negative function, okay? And then we're going to come up with all these other things here. So what we're going to do is I do have a little chart here to keep us organized. It's not that difficult. It's just there's a lot of information, so it helps to keep it organized. So what we're going to do is we're going to first find the x-intercepts. So here there's an x-intercept at -3, okay? And there's an x-intercept at -1. There's an x-intercept at 1, and then there's an x-intercept at +4, okay? Once you have found the x-intercepts, you're going to write the x-intercept as a factor. So whenever we're writing it as a factor, we write it where we set it equal to 0. So I'm just going to do this first one step by step, and then I'm just going to show you the shortcut. So technically, to write it as a factor, we need to set it equal to 0, meaning we move everything on one side to the other. So to move the -3 over, to zero it out, I have to add 3 on both sides. So you would have here x plus 3, okay, equals 0. So this is of the factor. X plus 3 is one of the factors, okay? And from our previous lessons, we write a factor using parentheses, in which I'll do that. I'll go ahead and put it in now. Okay, so this is the way you do it, but notice that all it really is it just changes the signs. If it's -3, it becomes +3. So if it's -1, you would write x plus 1. Okay, and then set a parentheses, and I'm not gonna write the equals 0 part. Factor kind of says that already. So just to clean it all up, so if you have x-intercept at x equals -3, so that means that x plus 3 is one of my factors. The reason is, and let me quickly show you this part. So let me bring up Desmos and just show you why is that. Well, if I want the graph to cross it at any given x-intercept, so for example, if I wanted to pass through x equals -3, if I put it as a factor, so if I put x plus 3, it goes through the x that I wanted to, -3. So if I put x plus 3 like this, then it goes through -3. Same thing here. If I want, let's say I want the x-intercept to touch it at -1. So if I were to graph it, I have to write it backwards. So it's x plus 1 is how it touches the graph at that particular x-intercept. And it's going to make more sense when we just put the whole thing together. Okay? Okay, so I wanted to go through +1, so I'm going to have to write x plus 1. And I needed to go through positive 4. So to be able to graph it, if I do x minus 4, it's going to go through positive 4. And the reason is whenever you equals 0, so if what makes this 0? So if I plug in um, -3 here, that's what makes it a 0. And that's x-intercept is where your y value is always 0. That's just more information that you really need right now. But anyway, these are the factors at these x-intercepts. Okay, now this is the a little complicated part. What is the multiplicity? So the multiplicity we get by looking at the graph and the way that it's touching or crossing the x-intercept. Okay, so for this one, it's going straight through. So we call this a single root. Okay, a root is um, basically an x-intercept, or a root is um, what makes your function a 0. So if I plug in -3 into my function, you would get 0 because at -3 it's 0. Okay, but anyway, this is a single root because it's going straight through. This root right here, you see at -1, the graph is going to -1 and then it's coming back down. It's going towards -1, touching it at -1, and then bouncing it off. It has this little, to me, it looks like a parabola type. And this is called a double root. Okay, so this, whenever it touches the graph and bounces off, we call this a double root. Okay, and then, oops, my bad. Now let's look at this intercept at 1. Well, it's going straight through, which is also another single root. Okay, and this one, this is a little tricky. It's going straight through. Actually, it's going through, but it's not going straight through. It's doing a little curve through it. Okay, and so we call this a triple root. Okay. Um, so this is a triple root at 4. This is a single root at 1. There's a double root at -1, and then there's another single root at -3. So how did these roots play into our functions? Remember, our goal is to write the function over here. All right, so we call that the multiplicity. Okay, so basically, if there's a single root here, there is a multiplicity of 1. Okay, there's a multiplicity of 1. And since there's a double root at -1, there's a multiplicity of 2. These end up being the exponents for each of your factors. At 1, there's a single root, so there's a multiplicity of 1. And here there's a triple root, so there's a multiplicity of 3. Okay, and all it is these end up being your exponents for each of your factors. Okay, so the 2 goes up here, the 1 goes up here, and then the 3 goes up here. Okay, so that's what the multiplicities comes from. And then again, these numbers, these exponents that I have here, um, come from the behavior of the graph here. Okay. And then identify the right end behavior. Basically, is it rising or is it positive or is it falling or is it negative? And we've already done that. First off, we said that this is a negative function because it's going down. Okay, so this is going to be negative. And then now finally we're ready to write the polynomial. So to write the polynomial, you start by, if it's positive, you don't write positive, you don't write plus, you just leave it blank. But since it's negative, I'm going to go ahead and write the negative. And then we just put all of these down here. Okay, so basically you would just put I'm not trying to be fancy here. Let me stop trying to be fancy. So you have the negative because the graph is going down, and then you just write all of this down. That's it. So you have here uh, x plus 3 to the power of 1 because there's a single root, and an exponent of 1 we don't usually write it. Okay, and then over here you put x plus 1, and then you do have to write this squared because there's a double root there. Then you have x plus 1, and then there's nothing there. I mean, there's a 1, but we don't have to write it. And then x minus 4. Okay, and this is a triple root, so I have to put the 3. So this is it. So if I were to graph this function, I should get the graph that I have above. So let's go ahead and do this. So you have f of x equals negative x plus 3 to the power of, oh, and then you have x plus 1. And look, the moment I put squared here, see what happens. It does, see it went through negative 3 and then it creates a double root here at negative 1, just like how I have in my graph. Okay, see it creates that double, see it goes straight through negative 3 like it does here, and then it creates a double root right there. Okay, we want a single root at 1, so to do a single root at 1, we're gonna do x, since it's positive 1, I put negative 1. Okay, so there's a double root here, and I know that the root is supposed to face down, but right now it'll go back down once I keep typing. And then finally this one, there's a 4x, since it's positive, I have to put minus 4. And then let me go ahead and make a triple root. There we go. Now this looks weird. It doesn't look exactly like this graph because you see how I changed my y value to like to show from negative 1,000 to 1,000 here. I can do that. So if you go here, you can change your y value. Instead of showing only from negative 5 to positive 5, you can change it from negative 1,000 to, oh no, that's x-axis, my bad. I'll put that back in negative 4. Let me change this. So you have here negative, if I change the view of this, there. Now that looks more like my graph here. Okay, so that one and then that one. It's the same exact graph. Okay, now see there's a triple root here, there's a single root, a double root, and so on. So yeah, that's what it is. Oh, what's all this? Okay, so in expanded form. You're not gonna have to do this, but expanded form is basically when you have expanded this all out. So this is a square, so there's you would write this twice. Well, I guess I can do it. I'll do it in blue ink. I'm not gonna multiply it out, but I'll show you. I'll at least get started. So you have x plus 3. So there's only one x plus 3. There's a single root. Since there's a double root here, what that means is you have x plus 1 and then x plus 1 again. Okay, that's being expanded. This is just 1, so this is just x plus 1. And then x to the third power, it's basically x minus 4 times x minus 4, I'm going to run out of room, times x minus 4. Okay, now where did they get this from? Basically, you're multiplying these out, and then you multiply, and then you multiply, and you multiply. You just keep on multiplying. It'll take you forever, but that's where this expanded form came from. But the important part is, what is the degree? So the degree is the highest power. So here, this is a 7th degree polynomial. We went over some of these in lesson 1. So the degree of this polynomial is 7, 7th degree. Okay. Now, how can I know that it's seventh degree without having to multiply it all out? Well, all you do is add up your multiplicities. So 1 plus 2 is 3, 3 plus 1 is 4, 4 plus 3 is 7. Okay, and how many zeros or roots does it have? Well, it has 1, 2, 3, 4 roots, 4 zeros. Okay, so basically 4 x-intercepts. Okay. So let's look at the practice page. So it says here, let's look at the zeros. So basically you have this graph here, and we're gonna have to find the end behavior, I mean, basically the function. So what you do is you go through, identify the x-intercepts. So there's an x-intercept at negative, can't really see that, but -4. There's an x-intercept at 0, and there's an x-intercept at 1. Um, right end behavior basically, is it going up or down on the right side? It's going up, so it's going to positive infinity. I'm just going to put positive infinity. Basically, we just want the positive part. And then now we're going to have to write our function. So since it's positive function, we're just going to leave it as positive. And then we're just going to write our function. So you have here an x plus 4, and then you have x, well, plus, there's no plus or minus 0, it's just 0. So I'm just going to put just x. And then here, positive 1, so I'm going to have to put -1. And then now we're going to have to see what are the multiplicities. So this is a single root, so there's a 1. This is also a single root, and this is also a single root. So this is my function right here. Okay? Let me do one last example right here. So you're going to go through, identify the x-intercepts, and -1, sorry, -4, -1, 2, and 3. So my x-intercept was -4. Oh, why is it not typing? -4, -1, 2, and +3. So, and then my right end behavior is negative. So it's going down. So this is going to have to be a -1. So that, which means that this is a negative function. Okay, so now we're going to have to, I'm going to type it. This pen is not really working. So, um, okay, so you have here negative, and so you have x plus 4, x minus 1, sorry, plus 1, x, that's a positive 2, so I'm going to have to write -2, and then x minus 3. Okay, I'm almost done here, except that I have to find the multiplicities. I have to look at the exponents here. Okay, so at -4, there's a single root, so I don't have to write an exponent. At -1, there's a double root here, so I do have to write the square here. At +2, there's a single root, and then there's a single root here, so I don't have to write anything. So this right here would be my answer. Okay?